Hello and welcome to another session in the Spark series. So in this session we'll look at why Spark is faster than MapReduce. We'll take an example and we'll see how MapReduce will process that application and then how Spark will process it. And then we'll know why Spark is faster than the MapReduce. Right? So what we're going to look at is a word count. So a very famous example word count where you have the data. So this is your input data. As you can see, you have Hadoop, user, Scala, and yep, these are the words that you have and they are repeated. So this is the data that we have, and what we wanted to find out is we want to find how many repetitions are there for each word, like Hadoop, how many times it is occurring, or user, how many times it is occurring. So this is your word count example, right? So if you're working with in a MapReduce environment, if you want to process this using a MapReduce environment, there are 4 steps, right? The first thing that you have to do is you have to load the data. So once you load the data, the next thing that you want to do is you want to flatten this data. So you want to divide this data based on your space in this case, so that every element becomes separate. So you will get something like this. This is your flattening, right? Now once you flatten the data, what you have to do is to every element you just assign a key, right? You just give it as value 1. So Hadoop 1, user 1. So every element or every word you give it the value 1. And then what you do is you are going to group the data. So you group the data on key, so Hadoop, and then you make a sum of, like, Hadoop is occurring 3 times, user is occurring 3 times, Scala 5, and Spark 1. So this is the process of MapReduce. The same process we'll follow in Spark as well. Now what is the basic difference between these two, right? So in MapReduce, what happens when you load the data is loaded and it is saved in the hard disk. Then when you flatten the data, it flattens the data and the result is again stored in the hard disk. Then it assigns a key, it stores the data again in the hard disk. So every time you do a transformation, every time you're making changes to the program, the intermediate results are basically stored in the disk. So this is the main reason where the MapReduce is slow, because the input output reads operations is what it is causing it to be slow. So every time you have to do something, you have to read from the disk, again you have to write from the disk, right? So lot of overhead is there. So this is the problem with the MapReduce, right? So this is where Spark has made a small tweak. Spark handles this a little different, right? Spark will have in-memory processing. Before we understand this, how Spark is handling this, so we need to talk about RDDs. So once we understand what RDDs are, then we will come back and see how Spark handles this, right? So what is RDD? A resilient distributed data set. So RDD is a collection or immutable collection of objects. It is a read-only partition collection of records. So basically RDD basically represents the data across nodes in a cluster. So you create an RDD that will refer to a data set. So just like we read the data from a file and we give it a file handler in Scala. So similarly, when you read a data, or you can read that into an RDD. So RDD will refer to the data. Now using this, you can create more and more RDDs, like you can apply some filter conditions, then it will create another RDD. So it will refer to this data. So that's what your RDD is. So it represents the data across nodes in the cluster. Now there are 2 things that you can do with an RDD. One is your transformations. The other thing is your actions. Now transformations are functions that change the RDD data, and it will result in another RDD. For example, your first RDD is basically to load the data, right? So you have RDD which loads the data, and then on top of this RDD you can apply a filter condition. Maybe you just want to filter out the records using city, right? So you filter out that records. Now the result will again be another RDD. So this is about your transformations. So transformations are basically your functions that change the RDD data and it will again result in another RDD. Now what are actions? Actions are functions that does not change the data but basically gives you the output. For example, count is an action. So what count does is it does not change your data. All it does is it counts the data and gives you the output. So that is your action. Transformations changes the data, it gives you another RDD. Actions basically gives you the final output. So these are the two basic things, right? Spark follows lazy evaluation. Now this is important to understand. This is where we are explaining how Spark is faster than your MapReduce. So Spark follows a lazy evaluation. Now this means that the transformations are executed and only check for syntax error, right? They are not checked for any other thing. We just look at the Spark just looks at the syntax. It does not store the data, it does not have any memory, it does not release any memory or give any memory. It basically checks your transformations syntax. Okay, they are not executed until an action is executed. This means no memory is allocated until the action is executed. So it will just check the syntax for the transformation, and while it does it, it will create a plan for the data flow. So how the data is flowing from RDD1 to RDD2 to RDD3, and then when you reach the action, it will start executing from action to RDD. Now since the plan is already created for each transformation, it will know which one to execute first, followed by which transformation or which action. So it has this plan. It does not need to store any data, it does not store any temporary data to the hard disk. All the processing is basically done in memory. So this is what we say as in-memory processing. So when the action is triggered, the plan is executed, and dynamically the memory will be allocated for each transformation and action. Now let's look back at our word count example and see how the Spark will process this. So this is your data. The syntax for this transformation is basically checked. If there is any syntax error, it will throw error and no memory is allocated. But at the same time, a plan will be created. No execution happens here. The next step is you're flattening the data, right? Again, the syntax for this transformation is checked. If there are any syntax error, it will throw the error. Again, no memory is allocated. A plan will again be created. No execution happens. So now you have loaded the data, you have flattened the data. So nothing has executed. It just creates a plan for this. Then we add 1 to the key. Again, a syntax is checked. If there is an error in the syntax, it will throw error. Otherwise, the plan will be created. No execution happens here. So this is your lazy evaluation. All this is happening because all of them are basically your transformations. They are just changing the data, right? Then comes your group by. So what group by does is it is going to give you the output. So this is an action. So here what Spark does is it will check the syntax, then a plan is created. So now you have the plan from step 1 to step 4, which is your loading the data to flattening, adding a key, and using a group by. So it has a full plan, right? And then because you have encountered the action, now the process will execute from step 1 to step 4. So it will load the data in the memory, and then it knows that it has to flatten the data. So the same memory will be used to flatten the data, and it will go all the way till your step 4. So nowhere it saves the data into your hard disk. It will do the in-memory processing. So thus it will eliminate those frequent IO hits. This is what makes Spark faster than MapReduce. The frequent IO hits, the input output hits in MapReduce slows down the process, while that is the tweak that Spark has done. Instead of frequently hitting the input output devices, it will do the in-memory process because it has the plan executed, and that's how your Spark becomes faster than your MapReduce. All right, so this is good. Now that we understand how the processing happens in Spark and in MapReduce, let's revisit the differences between these two, right? Just kind of a revision. So MapReduce follows a linear evaluation, goes from step 1 to step 4. And Spark on the other hand follows a lazy evaluation. It does not execute right from step one. It basically creates a plan. So MapReduce follows a top to bottom approach, that is the first step to all the final step. That's where it creates the execution. Spark basically follows from bottom to top approach. So it just checks for the syntax, and when the action is encountered, that's where it has this plan, and that's how your approach comes. From there, it will check for the plan and it will get executed. And MapReduce has a frequent IO hits because it does not have this execution plan created. So every time it has to save the data to the disk and then read the data from the disk. But in Spark, because the execution plan is created on the go, so this does not have to store the data in the hard disk. Rather, it can do a in-memory processing. And this is the main reason why Spark is much faster than your MapReduce. I hope you are able to understand how Spark is faster than MapReduce and what is the architecture of Spark and another thing. So again, these are things just for theory, but we will start working in the practicals very soon. But a small theory here and there we will add it so that you understand the basics, you understand how things come out, and it is always good to know what we are dealing with before we start working on it, right? So that's all I have for this session, and I will see you guys in my next session.